Hello friends, today in this video we will learn about Hack coupling reaction, palladium based catalyst used in this reaction, generation of palladium 0 from palladium 2 catalyst and mechanism of Hack coupling reaction. Hack coupling reaction involves coupling of vinyl or aryl halides with alkene in the presence of palladium 0 and base leads to the formation of two types of alkenes. So the formation of one of the alkene is major product, and this is known as regio selective. So you can see that this R group can go to the more hindered double bond to give this compound. If it goes to the less hindered double bond, it will give this compound. Now you can see that this compound has trans symmetry and there is no cis geometry product is forming. So because this reaction is stereoselective, so this reaction is regioselective as well as stereoselective, that we will understand through the mechanism why it is happening. This reaction reported in 1972 by an American chemist Richard Frederick Hack, in which he took iodobenzene reacted with styrene, 0.1 equivalent palladium acetate, 1 equivalent of N-tributyl amine as a base, and in this reaction no solvent was used and the reaction was performed at 100 degrees Celsius to give the trans stilbene in 75% yield. So in Hack coupling reactions, vinyl or aryl halides or triplets reacts with alkene in the presence of palladium catalyst and base. Tertiary amines usually used as a base in this reaction. When this reaction was performed first time, that time there was no solvent. After that, a lot of solvents have been used in this reaction, so that we will see in the next slide. This reaction is useful for the synthesis of substituted alkenes. You can see that there are various solvents has been used in the Hack coupling reaction, like acetonitrile water mixture, ionic liquids, DMSO, polyethylene glycol, DMF, NMP. These solvents are green solvents because these do not have any hazardous effects to the environment or human health, but because DMF and NMP has severe effects on the human health as well as on the environment. In 2014, Clark reported reaction of aryl halides with acrylic esters in the presence of palladium acetate, triethylamine and organic carbonates as a solvents. Like this is called ethylene carbonates because there are two carbon, 1 2, and this is carbonate group, so this is ethylene carbonate, this is propylene carbonates. They observed that ethylene and propylene carbonates have high boiling point similar to the boiling point of DMF and NMP. These carbonates are also less volatile, so less emission in the atmosphere. These carbonates are safer in handling and less toxic as compared to NMP and DMF. So if you want to perform Hack coupling reactions, then you can use cleaner solvents such as organic carbonates instead of using DMF or NMP. These are the catalysts used in the Hack coupling reaction. This is called tetrakis triphenyl phosphine palladium 0 complex. This is called palladium acetate. This one is palladium dichloride, and in this case palladium has +2 oxidation state. So if you use +2 oxidation states, then we should know how we can convert into the palladium 0 in C2. So palladium 2 can be converted into palladium 0, which is the active form of the Hack coupling reaction. Using phosphine we can convert, using alkyl amines also, and using alkenes also. So if you are using phosphine, then you have to take phosphine in excess amount, which will react with the palladium acetate. It will cleave the two palladium oxygen bond and forms a new palladium phosphorus bond, which will undergoes rearrangement, and the negative charge will come on the palladium to give this anionic complex, and this will be the cationic compound. Here palladium has 0 oxidation state, which will further react with the 2 mole of triphenyl phosphine to give stable complex, and water here will remove this acetate in the form of acetic acids, and hydroxide of this water will attack on this phosphorus to give this compound, which will undergoes rearrangement to give triphenyl phosphino oxide. And you can see now we have palladium 0 complex. If you take amines, then amines reacts with palladium with the removal of one of the chloride, and then it undergoes dehydropalladation to give complex A. In this complex, palladium still have +2 oxidation state because hydride and chloride both are negative charge ligands. This undergoes reductive elimination to give palladium 0 complex. If you take alkenes, then alkenes first coordinate with the palladium to form a complex. This undergoes insertion to form the palladium carbon bond, and followed by beta hydride transfer to give A complex. This A complex again undergoes reductive elimination to give palladium 0 complex. If we use organometallics such as butyl lithium, then two equivalents of butyl lithium will remove the chloride, and it forms this complex, which will undergo reductive elimination to give the palladium 0. Now look at the mechanism of Heck coupling reaction. First, palladium 0 complex undergoes oxidative addition reactions with halides, and this oxidative addition is trans. That's why R group comes opposite to the halogen. After that, alkene form the pi complex with the palladium. This complex undergoes syn insertion to form palladium carbon bond, and this R group goes to less hindered double bond carbon atom. Followed by internal rotation of this complex, hydrogen at the beta position can be cis to the palladium. Then it undergoes syn beta hydride elimination to give the trans alkene, which forms the complex with the palladium. This complex then dissociate to give the alkene as a product, and palladium 2 complex then undergoes reductive elimination to give palladium 0. Now you understand that regioselectivity in the Heck reaction is due to the steric effects of the reactant olefin. Here you see that palladium goes to the more hindered carbon atom, while R group comes to the less hindered carbon atom. Steric hindrance at this alkene governs the regioselectivity of the Heck reactions. Stereoselectivity governed by beta hydride elimination. So syn beta hydride elimination is responsible for the formation of trans alkene. Thank you very much for watching this video. If you have any queries, don't forget to comment there.